Okay, so we would like to implement this binary search. Okay, so the binary search, just as a reminder, it just first of all, it's very important that the array in a binary search should be sorted. If it's not sorted, it's not going to work. It's not like the linear search. The linear search, it can work without any sorting whatsoever. And so the linear search, basically, if you remember, we saw it, what it does is just starts by saying that this is, let's say, the position is -1 to find what's the position of the number we're looking for. Now let's say this is the number that we're looking for. We're looking for n that is given to us by the user, and then we just go from the array, from the first element of the array until the last one. We check one by one if the element of the array is equal to the number that we're looking for, that the user has entered. If it was found, I'm just going to remember what position of the I it was found in, and then stop. If it was not found, let's say I'm looking for a number that does not exist in the array, this is going to be always false, because the number does not exist in the array, so it cannot be equal. So it will be always false. If it's always false, I'm not going to be doing anything inside here, which means the position is going to be -1. So if at the end of this loop the position is still -1, that means I did not find it. If it's not -1, that means, okay, I found it. So we said that this is the linear search. It just starts from the beginning until the end. The linear search's main advantage is that it's very simple to implement. A very simple algorithm. It doesn't require a lot of things to do. Now the disadvantage of that is that if my array is very big, it's going to check each one of the elements one by one until it doesn't find it. For example, the worst case scenario is that it just looks for that number that doesn't exist into like 200 million elements into the array, which will take a lot of time. Now there's this different way to do things, which is this binary search. What the binary search is going to split the array in two, and that's the idea behind this website. So let's say it's going to have this array of 32 elements, so we need to look for a number, but first of all we need to realize that all the elements in the array have to be sorted, either in a ascending order or descending order. It doesn't matter. The only thing that will change is the way I'm dealing with the code. But let's assume now in the ascending order I'm looking for 350. I know that this 350 exists because I'm looking at it. This is here. Now if I just look, maybe just click on binary search first, so it's going to just start by finding the middle, and then that's what we need to do. So the first thing is, let's stop here. The first thing what we'd like to do is to have this low, mid, and high, because we're going to be changing those values depending on where do we find this element. The advantage is that we're not going to be looking into the whole array. We just look at one and this one in the middle, and if my number is smaller than the one in the middle, I'm going to look on the left of the middle. If it was higher, then I'm going to be looking at the right side. The first advantage is after my first question, I'm eliminating half of the array, which is a good thing. Imagine now that the array has 200 million. I just ask one question and then 100 million is gone. So that's the main advantage of that. But the prerequisite is that the array should be sorted. If it's not sorted, you cannot do that. And then we're going to be repeating this thing until we find the number. And then let's play again. So we're just going to be again having the middle, and then we're going to see the number. Is it equal? No, it's not. So is it bigger? Yes, it is. So I'm going to be looking on the right side. So is this the number? No, it's not. And then is it bigger? No, so it's smaller. I'm going to be looking here, and it's going to be doing this until it finds the number. Like for example, in this case, that's the last one. Then it was found. Just give me the position. So that's what we're going to be doing. So this is basically the code. It was given to you, so you just need to implement that. Just an implementation of this is that this is some kind of a method that's called binary search that takes the list of data, which means this is the array, and then the value to look for, which is the value that we're looking for, is this value, for example. And then we're going to be repeating this thing until either we find it, we find that the value was found, that's where we return something, or we get out of the loop without returning anything inside of the loop, so we need to get out. But how do we get out of the loop? Is that we need to have a look at what's the condition that makes the loop, that make us finish and not keep going until limit. And if we would like to see that, let's just look for a number that doesn't exist. Let's say I'm looking for 1. Sorry, not the linear search. I just would like to restart again. Let's look for 1, and then 1 does not exist. I'm just going to look again for the binary search. So the same process needs to happen, but at one point it will stop because we'll not find it. Every time it's going to just split. Just make it go faster. So it's just going to be splitting, split up. Okay, well, okay, but I just skipped it. But the thing is, what is going to happen here, because every time if I don't find it on the right, I'm just going to make the high become smaller. It becomes like this high becomes smaller than the low, and that's the condition. I'm going to stop when the high is not high anymore. It's smaller than the low. So high should be bigger than the low. So as long as it's bigger or equal, I'm going to be repeating. Now I'm going to do this one step at a time, and then we'll find the loop in that part. So what I'm going to do, just let me create. Oh, you know what? Let's keep this one. What I'm going to do something a little bit different. First of all, let me just copy and paste. Okay, and I'm going to call it now binary search. Okay, so this binary search now, I am going to, of course, need to have not to initialize an array and then randomize it. I'm just would like to initialize an array and put the values myself. And I'm going to put the values that I know that they are sorted. For example, like this. And something is, I'm sorry? Oh, between 5 and 6. Yes, thanks. So now this is going just to display the array, and then I'm going to ask you to give me a number, and this is where I'm going to be looking for that number, and then I'm going to remember the position of that number. So either it's -1, or if I don't find it, I'm going to say, well, I did not find it. Now, in order for me to do that, what I need to do is, first of all, to split the array into 2. So I need to be able to remember which one is the low, which one is the middle, and which one is the high. So when we start the first time, the low is 0, the high is the dot length -1, because dot length is going to give me, in this case, 10. Where's 10? So it's going to give me 10 because there are 10 elements, but it's from 0 to 9. So the position here should be 9. And then the first thing that I'm going to do is to make a loop. I need to repeat something. What am I repeating? I said the condition is that I'm going to repeat something until the high less than low. But if the high is less than low, I'm going to get out of the loop. So I need to get in the loop when it's the opposite of this, which means when this is greater or equal to the low, I'm going to get in. And when it's going to be false, that means the high is going to be smaller than the low, I'm going to get out. And the first thing I'm going to do is to calculate the middle, which is high plus low, or low plus high, divided by 2. Now I'm dividing an int by an int, which makes sure that this mid is going to be an int, because this is going to be like a position that I'm going to look into the array. Now what I'm going to do is the first thing I'm going to check is if the array at the mid is equal to the number I'm looking for. So if that number is found, what should I do? That's it. I just need to remember the position, which is the mid, and that's it. Let's get out. We don't need to continue. But if it's not, now I need to check. I need to now change the high and low based on if the number that I'm looking for is bigger or smaller than the mid, the value inside of the mid. Now if, let's say that the array of the mid is bigger than the number I'm looking for. So if the array of the mid is bigger, let me just start anew here. Imagine that my mid is here, and then the number is smaller than the array of the mid. This number that I'm looking for, let's say 44, is smaller than the value in the mid. What should I do? The low should not change. It's that the high should change. It should change to what? To the mid? I could put the mid, but I'm just having an extra step because I know that the mid is not part of it. It's not exact, it's not the value. So I can just take the one before it. So I'm going to be checking just from the 0 until the mid minus 1. Because I don't need to check the mid, I just compared it with the mid earlier. I found that it's not equal. That's what I'm here actually. So then if it's the case, so if the array of the mid, the value inside of the mid is bigger than my number, I need to make the high become smaller. So the high now becomes mid minus 1. And if it's not, that means it's not equal, it's not bigger than the number. That means it's smaller than the number. So for example, if the number that I'm looking for is 800, and then I ask, is the mid is equal? No, it's not. Is it bigger than the number? No, it's not bigger. So it's smaller than the number, which means now I need to look here, which means the low should change to become the mid plus 1. So now the low should become mid plus 1. Once it's done, I just need to continue on repeating until one day this high is going to become smaller than the low, and then this becomes false and I get out, and then I'm going to see if the position changed sometime, if I found it. The only time that the position is going to be changed is when I find it, and if I find it, I'm just going to find it and get out. If I don't, I'm just going to be repeating until I get out from the loop. Shall we try it? Let me try that. I'm going to now, when you have in NetBeans two classes, both of them they have the main. You see this, I have the main here and I have the main here. Now NetBeans, if I just click on this run, what I'm going to see is basically the one that was the default one here. You see this one? It shows me that this is the default. Actually, it's not normally it should show me the same here, but I don't know why it doesn't. But it starts with the first one that was there. Now this is the one with the linear search. I don't want to have the linear search. As you can see here, W6 week 6 linear search. That's not the one I would like to run. I would like to run the other one. So this one. So I have two options. Either I right click and run file, either here or here. Then it's going to run the file, and this is the file. It's going to see this is still linear search. Well, yeah, because probably this is the project is called linear search. Let me just rename that project so it will be less confusing. Yeah, I was confused. But let me just rename this. I'm just going to call it search. And rename also the folder. Okay, now if I run it again, that's not the one, this one. So if I run this, right click and run the file, it just that's the beauty of. I need to do some kind of cleaning, I'm guessing. Let me just run again. Yes. So now you see this is still the search because this is the project, but then I'm seeing this binary search. So this is one way, but if I would like to make this, I click on this and then it will work the same way it was working before with the linear search. I need to do another step, which is I need to right click on the project and go to properties. And then in the run here, I can select which one is the main class. Now by default now it was the one that was initially the main class, the linear search. If I don't want that, I can browse and it will tell me what other main files are available there, main classes are available there. This is the binary, just select this one. Now this becomes the binary. If I now just click on this, it is going to run all the time the binary. Even if I open this one and make a change, I just click on this one, it's always the binary search that is going to be run. So what to do again? Right click, properties, and then in the run you just change here in the browse, you select which one is going to be your main. So now let's run this and try to look for a number that exists. Let's say 9. 9 was found at position 8, so it can be there. So that's what if it doesn't exist? I'm looking for 11, so it was not found. Now I just would like to do something differently. What if I'd like to have one class and 2 different methods? Let me show you what I'd like to do. I'm going to create a new class. I'm going to call it search. And then I just would like to have this class to have 2 methods. Basically, I'm going to use them the same way that I need to use them, like the math.random or .pow or whatever it is, sqrt. So I'm just going to make them public. It is going to return something. Yes, it's going to return just the position. If it was found, it will be a number other than -1. If it was not found, it's going to be -1. And then I'm just going to give it a name, so it's a linear. And what it will take 2 things: an array and the value to look for. So you give me an array and a value, I'm going to do a linear search and return the result. So now, doing this, I don't know what's the array, what's the size, whatever, but I can just do the same idea that I was doing before. Now I need to return something. So what I'm going to do is I'm going to say int the value that I'm going to return. So let's call it the position. So the first time is going to be -1, and then I'm doing a linear search, which means it's a for loop from 0 to a.length. I don't have array. And then what should I do? Sorry? And it's if a.i or value is equal to a.i, so if it's equal, so I can do position is equal to I, and then I can return the position immediately, which will work as a break because I'm going to stop and return the value. Now if it's not the case, I'm going to return the position. That means if I got here, I got out of the loop, that means I never got inside, I never returned anything, so which means it was not found, so it should be returning -1. Then do I really need this position? Not really, because I can just do something like this. If I find it, I just return I. If I don't, return -1. And that's the linear search. Now how to use that? Let me put this inside of refactor. I just would like to put everything in one place, and what I'm going to do, I'm going to change now this first of all the package. I just would like to rename that package refactor, rename, because I don't want it to be linear search. I just make it search, wake 6 search, so it will be less confusing. And now here in this linear search, I just would like to call my method.
The search class.
Yes.
We didn't initialize we didn't put any value to the array.
Exactly.
So what's the different length for?
For now, we did not put anything, any size of the array. We just put the general idea. If you give me an array and a value, I'm going to see if the value is in the array. Now this will not work until this method cannot work until I give it two things, the array and the value. So I need to initialize the array and give it to this method first. So now I just would like to create a new instance, search s equal new search, because this is the only way for now that I know that I can use s.linear, right? Now s.linear, I just need the array that I just initialized here, well, like this, and then here we have n, which is the value that I'm looking for, and this returns what? This returns the position. So I'm going to make this position to be like this. Now this is going to return the position. If the position is -1, that means it was not found. If it was found, it will be, this is the position. So this position, this value is coming from the linear search, this code over here. If I run it, so again, because now it's the linear search, that was the binary search, sorry, that was the default one. What I'm going to do, I'm just going to run, let me stop this one first. And let's rerun the file. So this is the random array that was generated, 20 elements. I'm going to look for 0, if it's there, and it was found at position 4. So this processing was done inside the method linear, and it was done there. Now there's a better way, because you see this search class does not have any, I don't need to really create an object, because the only thing that I just would like to be able to access the method, so I can make it something that works like this. I just would like to, for example, do something like this. So what should I do to make it work like this? No, I don't want to use new. Like for example, math.random. You see this one? Did I use new math? So how comes that this is math.random is available like this? I can use it just immediately without instantiating. No. Because? No, I did not extend anything. Well, it's from Java. I know it's from Java, but it's available. I don't need to import it. It's from java.lang, which is available already.
Should you make it integer?
No. No. Final. If I make a class final, what does it mean? It cannot be. No, it can be accessible. It cannot be changed. No. You're so formatting your computers quickly. Finally in the class makes the class not extendable. I cannot, not accessible. Accessible, I'll make it private, it will not be accessible. No, it's not the same. Accessible is not like, not inheritable. That's different things. But again, if I want to use something like this, I just need to make it static. The method should be static. If I make a method static, I don't need to instantiate an object to be able to access that method, which means now if I just do this, this is okay, this one off. I don't need to create an instance, an object, to be able to access an instance method, a method that is static, because static means it belongs not to an instance but to the whole class, and that's how you can use something like this math.random. The final here in the class means this class cannot be inherited. You cannot inherit from class. You cannot extend from class math, which is you cannot inherit from class math. If you try to create a class that extends math, you'll be having, sorry, you cannot inherit from final math, because that's what final does. Final makes it not inheritable. But if you want a method to be accessible without the need of creating an object, you just make it static. Java 1, by the way. at the last week of Java 1. But even, you forgot final, which is like 2-3 weeks ago. How am I expecting you to remember Java 1? So anyways, now I have something like this that have a linear search, and I can do the same with the binary search. So public static int binary, which is going to be also needing the same thing. It needs a value and then the array to look for. And I'm going to be doing again the same thing, except this time I'm having a while. But a while needs the mid and low. Sorry, the high and low. So I need to declare those. So I need to have this low. The first value of the low is 0, and then the high a.length -1. I should not forget that. And then now I can have a while that is going to be comparing if the high is bigger or equal to the low. Then the first thing I'm going to calculate the mid, which is low plus high divided by 2. Then I'm going to check. But I did not declare mid, so I need to declare it. Now I need to ask a question. If what? Is equal to the value, then I need to return the value. I would like to have the position, which is the mid. Else if I need to know if it's going to be on the right or on the left. So what if, for example, I put if a mid is smaller than the value? Let's change it. It's bigger than the value. Now, if it's the value in the mid is bigger than the value, which means hold on. Let's just make sure we understand. So I said that the array here, the value here is bigger than the value, which means I'm in a situation where I'm looking, for example, like I'm looking for 8, while the middle is 599. So the high should change. So the high, mid -1. I wanted to do the opposite, and then I ended up doing the same thing. Anyways, else, then it's the low that is going to be mid +1. Is that it? I need to have the return -1 when? If the while finishes and I did not return anything, that means it was not found. And I'm returning -1. Now I just can do the same thing here. Instead of having to do this thing, I am going just to call search dot binary with the array and n, and that's it. Now if I run, the number should be, let's say, 5, so it's going to be found at position 4. And if it's a number that doesn't exist, it's not found.
So if we have like the difference between linear and binary, it's the time that to find the number.
Yes. If we would like to calculate how much time it takes, it will be significant if the array is kind of high, to be able to do that. And then there's some kind of code that allows us to count the time and then say the difference between the time when we start and we finish. But that's not something I'm interested in right now.